Good evening, how are you doing? I'm Mr. Ish. Thank you for joining me for this video. We're looking at the hyperbolic sine and hyperbolic cosine definitions, but with the graphing perspective. This is useful information to know, especially for students leaving pre-calculus and going into calculus, or those students who are looking at pre-calculus for the first time, because this perspective that I'm offering you or showing you is not routinely shown. To most students, this ends up being new material, so let's present this out over here. What we need to do is look at everything with regards to this perspective, a e to the x. Right there, y is equal to a e to the x. It's an exponential function. It is a function. You're looking at everything here with the coefficient a equals 1, and again later on with the coefficient a equals half. We're looking at everything here with the coefficient a equals 1. You can look at something here with the 0 comma 1 y-intercept, and here 0 comma minus 1 y-intercept, of which 3 of these 4 graphs which I'm showing you are relevant, but we will put all 4 just for completeness sake. You have something like here which looks like this. It's e to the x. You have a mirror image of that, and you're looking at that. You have here e to the minus x. You have something which comes across from this direction. It's a double reflection of e to the x. It's e to the minus x with a minus here. And then you have something which comes across looking over here, which is a reflection of e to the x but across the x-axis, and that's minus e to the x. Exponential functions which are relevant to what we're looking at over here today are this one, and this one. This one right here is not relevant. It just isn't. When you look at everything here, you're seeing how everything with regards to y-intercept is 0 comma 1 or 0 comma minus 1. Coefficients are all 1. So keep that in your mind as we look at the next series of graphs. Remember, all of this is helping us develop the definitions of hyperbolic sine and hyperbolic cosine. And again, this is just a single perspective of doing this. Look at the same thing over here. Now we're looking at a equals half, but this time we'll only show you 3 curves, the relevant ones. Here and here are going to be 0 comma half and 0 comma minus half y-intercepts, because it's no longer a equals 1, it's a equals half. That's what we're looking at. Our one curve ends up very well being that, and that's half e to the x. We're going to show you this in terms of pairs. Our other one ends up being this one right here, which is minus 1 over 2 e to the minus x. If you borrow elements from this curve and if you borrow elements from this curve and you add them up in terms of their elements, think very well also to the y-intercept. The y-intercept here is a minus half, the y-intercept here is half. If you were to likely add these y-intercept, minus half plus half, you'll get a 0, right? Minus half plus half is a 0. You're literally borrowing elements from both of these curves, functions right here. Remember, I'm showing you a good perspective here with regards to definitions here of these two. When you borrow these, you summate those elements, you end up looking at a curve which develops very much like this. It adopts this curve here in this quadrant, adopts that curve here in that quadrant, and you end up generating what is the hyperbolic sine hx. Because it is borrowing the elements of both of these, you end up having something which looks like half e to the x plus minus 1 over 2 e to the minus x. When you combine all of this using simple algebra, you end up seeing e to the x minus e to the minus x over 2, and this here serves as a very good definition of a hyperbolic sine. This right here is by no means a proof of that. We're showing you a perspective by which how this, in terms of graphic procedure, can show you that this exists in terms of hyperbolic sine. That's all we're showing you, nothing more than that. Everything here is a good summation. Minus half plus half giving you a 0. The elements from here, both of these combining to give you the hyperbolic sine. So this one right here, in terms of the hyperbolic sine, looks good to me, and it's done. With regards to the hyperbolic cosine, now you're looking at only this 0 comma half, a shared y-intercept between two curves, one which is this, half e to the x, and one which is this, half e to the minus x. If you are assuming that the hyperbolic sine and hyperbolic cosine are obtained from the sum of the elements of each of these, therefore when you look at the intercept here, half, you're borrowing half from here, you're summing that, you're going to end up at a 0 comma 1, right? Half plus half is a 1, so you end up getting a 0 comma 1, and then the elements of this curve and the elements of this curve are combined to give you a total, that total curve being the hyperbolic cosine. You end up seeing a curve which looks very well like that. And my hand is a little sloppy here, but you know what I'm talking about in terms of the hyperbolic cosine. And here the hyperbolic cosine, which indeed is a true function, ends up borrowing the elements of both of these and ends up looking at half e to the x plus half e to the minus x. When you combine these just using algebra, you have e to the x plus e to the minus x over 2, and this curve with regards to its definition, or this function with regards to its definition, is shown to be true by this simple graphic procedure where everything is assumed to be the summation of both of these. So that has been done. And this video doesn't have to be any longer than that, because most of everything else, for most of you calculus students, you are familiar with that. We know these are continuous functions. We know one of these is an even function, the other one is an odd function. One of these fails the horizontal line test, the other one passes the horizontal line test. Hyperbolic sine, if I were to draw it here on the same curve right here, same graph, we know the hyperbolic sine is a continuous function just as is the hyperbolic cosine, but we also know going from left to right, the hyperbolic sine is an increasing function, but the hyperbolic cosine is decreasing up to this x-axis value of 0, after which it becomes an increasing function. These are all the variety of attributes of those two functions. But anyhow, in this video, our purpose was specifically to focus on this aspect and to focus on this aspect and develop the two definitions of hyperbolic sine and hyperbolic cosine by utilizing this perspective, and we've done that for you. Thank you for watching. Have a nice day.